Hey everyone, David Shapiro here. I just have a really quick update. I wanted to share an insight that I had about how to implement Raven, or natural language cognitive architecture. Um, Basically, what I realized was, um, because Raven's going to run as an instance, probably in a container, I can actually use a shared file system for a lot of the memory. And so what I mean by that is, well, let me just show you. So unfortunately, I can't have the services running because I'm using the audio services of my computer. But basically what it does is the microphone will capture a sequence of audio files, which can then be used for inferencing things like speaker recognition, speech to text, that sort of thing. And it'll be cached here and then used, and then it'll be cleaned up. So it'll just be a buffer, and then it'll be translated into normal text here. So you see, oops, there it is. So you see, it's speech to text, and that's basically kind of the gist of it. There's still a lot of services to set up. Here's me drinking a beer. So this is basically what Raven sees, and that will be translated into text via inference, image-based inference. And so that's what I'm working on now, is setting up these services. And then there's another thing. So that's the audio cache and the video cache. So that's basically the sensory buffer for an AGI. Next is the heartbeat. So you know how you can be aware of your own body? It's called proprioception. This is basically Raven's proprioception. Every service that runs is going to create a heartbeat file here, and every time that one of those files cycles, it will update the timestamp. So this way, Raven will be aware of the services that are running. There's a whole bunch of other services that I need to work on. I don't want to spoil anything, but they're coming. So microphone and camera, that's the timestamp that they were running last. Here's the services. You can see it's just 64 lines of Python. Some of it is comments. So these are very small services. They just use files to share. And then what I'm going to set up next is the speech to text service, and then a video inference or image object detection inference. The advantage of having it set up this way, let me go back to the folders, sorry. The advantage to having it set up this way is that any number, an arbitrary number of audio processing services, can use these files. So let's say in the long run, I'm going to have music recognition, ambient sound recognition, emotional tone recognition. There's going to be all kinds of services using these audio files to generate inferences. And you see the fact that every audio file has a timestamp attached to it. That means that Raven will know exactly when he heard what. So that's pretty cool. And same with the video. Again, there's me drinking a beer as I'm getting set up. So right now, the frame rate for this is 1 frame per second, or actually it's every 2 seconds. That's because it's expensive to run this stuff, and it would be excessive to run it at any higher rate. In the future, Raven will be updating the vision at, like 1 frame per second, 2 frames per second, 10 frames per second. And eventually, as the technology gets cheaper and faster, Raven will see as fast as you or I do. That might be 5 or 10 years down the road. And then the memories, so everything that enters Raven's consciousness, the AGI's consciousness, will end up as a log file here. Eventually, I'm going to transfer this into a private encrypted blockchain, because they're chronologically sequential. Everything that Raven thinks, sees, hears, says, everything is going to end up here in the memories directory. And then it's going to be encrypted and put in a blockchain for privacy's sake. But for now, I'm just using log files. I'm thinking about using something like syslog. There's a technology called the Elk Stack, which is Elasticsearch, Logstash, and Kibana, which is a tool for capturing and visualizing logs. Because that's essentially what the content of Raven's consciousness is a series of log files. It's that simple. And I know all of this looks really simple. It's not complete yet, so keep that in mind. And you might think of it as elegantly simple, but I also think of it as deceptively simple, because just because something is complex or next generation, right? That doesn't mean that that it has to be complex or over the top, right? Simple solutions are often the best solutions. So, anyways, that's it. I just wanted to post a quick update about this. Thanks for watching. Bye.